Today's lecture is about the USDA soil taxonomy, the USDA, specifically the Natural Resources Conservation Service, NRCS, previously known as the Soil Conservation Service. This is a map of an earlier taxonomy system, an earlier way of classifying soils. This was the work of one of the first soil scientists, one of the more important soil scientists of the 20th century, Curtis Marbut. And Marbut, under the USDA, they created a system in 1938 that lasted for quite a while. 1938, you can imagine, it's coming out of the New Deal. The Soil Conservation Service was created in 1935 as a permanent entity in the United States Department of Agriculture. Remember that originally it started out as, remember what it was called? The Soil Erosion Service, right? Soil, they help you erode your soil. It's just kind of a bad name, the Soil Erosion Service, but it got started under Bennett, H.H. Bennett, and in 1935, if you've watched that video that I posted, you'll see that the Soil Conservation Service was established. Initially, it was under the Department of the Interior, but they moved it to the Department of Agriculture, and that's where it is today. So all of this stuff is pretty much USDA, it's agricultural stuff. And so in 1938, this initial soil taxonomy comes out, and this older taxonomy is based in a descriptive system. It's essentially the empirical evidence is there, and that's what we use to describe the soil types. I like this old system myself. It has wonderfully descriptive terms. Like, for example, in our part of Oklahoma, here in Payne County, this yellow area is referred to as the reddish prairie soils. Okay, so you can't get more descriptive than the reddish prairie soils, and we all know what those look like if you're from central Oklahoma. But the more recent system came out in about 1960. So in the 1950s, they started experimenting, and they came up with what's referred to as the seventh approximation. All right? So the seventh approximation soil classification system released around 1960, and that's what we've used ever since. And this system of classification, this is kind of a soils geography. All right, this is kind of what we look at in my field in terms of understanding soils. But we're going to just literally scratch the surface of this system today. But here's a little bit on the way this looks. The NRCS uses 6 levels of classification in the seventh approximation system. The top level, and this is a hierarchical order or hierarchical system, the top level is the soil order. These are the most generalized soil classes that we could come up with. And there are around a dozen of them, and we're going to look at those 12 soil orders today, and I'm going to introduce some characteristics of those orders to you. Like I said, if this is old stuff to you, I apologize, but it's important for everybody to know about the soil orders in the class, so they can have some idea of the magnitude or the degree of importance of those good soils that we have. All right, so anyway, you have soil orders, you have suborders, great groups, subgroups, families, and the series. And the series is the most localized scale of all. This is the end series, or the end classification. And the soil series is getting to that concept of the pedon, right? This sort of this general idea of a particular type of soil. Now, you can continue to examine a soil at the scale of, a human being, which is a little bit below that, and then, then we can go microscopic until we see, variations in soils just in a sample. But the soil series is what you'll see on those maps in the county soil surveys. If you've looked at those county soil surveys in hard copy, they contain a bunch of aerial photos, and on those aerial photos are drawn polygons, and those polygons represent individual soil series. So that's the largest scale from a map perspective, the largest scale that we have with regard to the soils. Right. So that's the old order. This is the new order. And this is the map of Oklahoma under the 7th approximation system. These are, you only see 7 of those 12 different orders. And basically, these are the 7 that you locate within Oklahoma. Now, obviously, they're not evenly distributed, and there's a geography to them. So which of these is, makes up the largest amount of soils in Oklahoma? What? So we have the dark green, which are the mollisols. We have the lighter green, which are the alpha sols. We have this sort of orangish area over here in the eastern area, eastern parts of Oklahoma, the Ozarks and the Ouachitas, ultisols, and the inceptisols, generally associated with the Gypsum Hills area. And there are a few other small examples. So these are the ones we're going to look at. I'm going to remind you of where they are in Oklahoma. So let's start out alphabetically. We'll start with the alpha-sols. Alpha-sols. And these are soils associated in Oklahoma with the cross timbers. That's the area basically where we are and a little bit to the east, Sandstone Hills area of Oklahoma, cross timbers, biome. And then a little bit out west in the Gypsum Hills. They're associated with humid forests, mostly humid forests, but you also find them in areas that are sort of transitional to humid grasslands. So that's Oklahoma, right? Cross timbers and transitional prairie. It's a really pretty common type of soil. It's the second most common soil type in the world. And they have fairly well-developed clay horizons. So that means that you have an A and an E, a B horizon. And the B horizon is where you're going to find for the most part, the clay. The mineral content of the topsoil in an alpha sol is usually pretty good, with plenty of calcium and magnesium and potassium. I was going to put the chemical notation, but I decided not to. These are again among the more productive soils on Earth, and we have a lot of them in Oklahoma. They are a little bit different from the mollisols, basically in that they receive more moisture and a little bit more leaching than the mollisols. Mollisols, as we'll see, tend to be a little higher pH, which is a little bit better even better for agriculture. And so they're often found associated with mollisols. Now, if you didn't get all that, remember, recording, you don't have to necessarily jot it all down at the moment. Okay? So if I can get this thing correct. Next. Where do we find the alpha sols? You can see this is the cross timbers region, sandstone hills for the most part, down in the southern part as well, and a little bit along the Gypsum Hills. Notice that they're generally associated with the northern sides of the rivers. Why might that be? That's something to do with movement of soil. The prevailing winds in Oklahoma, even though it's back and forth this time of year between north winds and south winds, for the most part, the strongest and the most constant winds. If north and south is battling out, in Oklahoma, the south winds win, all right? The south winds tend to be prevailing throughout the year, and that means that sediments that are deposited by rivers tend to blow out of the river valley or out of the floodplain onto the north bank, okay? That's what you'll always see. You'll see wind-deposited materials on the north banks of rivers, and you'll see some more examples of that. Next, alphabetically, andesols. Andesols are not really found at all in Oklahoma because they are associated with volcanic ash, with volcanic eruptions and ash plumes. You might find them in Washington and Idaho and Oregon, and associated with the Cascades, an active volcanic system. Some of the better soils in the world are actually andesols, and particularly in tropical areas where oxasols were predominant and where fertility is not very common. You'll generally find dense populations of farmers around volcanoes and other areas that have these ash deposits. So andesols are highly sought out by farmers, and we can look at around here, the Rift Valley of East Africa, Mount Kilimanjaro, for example, has lots of these spectacularly fertile volcanic soils. And so you have high populations associated with Java in Indonesia, an island in Indonesia. We associate Java with coffee as early coffee plantations, but very high population densities associated with production of rice and other food crops in those andesol regions. So andesols, as associated with volcanoes, make up less than 1% of all global land area. So they're one of the precious types of soils in the world. Not very common, but where they exist, they're highly sought after. Next on the list, aridosols, and this is a real descriptive term, right? Arid. And sol in this sense referring to soil. The aridosols are, for the most part, non-leached. That means there's not any water moving vertically through the soil column. Not any water over a long period of time, at least. So without any leaching going on, you don't have the vertical movement of of minerals from the surface down through the soil column down to the B and C horizons. It's also associated, because they're associated with deserts, they're going to have low humus content, very little organic material. And also because they're in usually warm environments, hot environments, that organic material might be desiccated very quickly anyway. So associated with semi-arid grasslands and deserts. We have a few in Oklahoma classified as aridosols, but not large areas. Now, interestingly, I was thinking about this on the way over here. You know what the proportion of the Earth's surface, that is water. What is that proportion? Remember that? How much of the Earth's surface is covered by ocean? Like 78%, something like that. And then we've got a lot of the land surface in the polar areas that are completely covered by ice, like Greenland and Antarctica. There's no soil to speak of in those places, right? So, technically there probably is in Greenland and maybe possibly in Antarctica, along the rim of the continent, along that peninsula. But, for the most part, that's out. So you've got what's left is the easily less than a third of the planet's surface, which is land masses. Okay, so we've got less than a third. We could just say probably a quarter of the Earth's surface is land mass. Now, this is my my laptop outperforming the projector. That's what that does. It'll come back. It flashes like that, so just ignore it. So we've got maybe 25% of the land surface that's even not frozen all the time. All right. Now of that quarter of the total land Earth surface, think about the proportion of the Earth's surface that's covered with soils that really aren't of any use for production of agriculture. Okay, so this is a good example. Even though the iridosols might be fine for pastoralism, for grazing, cattle ranching or something, sheep ranching, it's not necessarily always desert. So, but 12% of that land area that has some potential for agriculture, 12% are iridosols. That's a lot. Right? So the point here is that the amount of land that we have in good shape is really a tiny percentage of the whole. All right, well in Oklahoma, and I like to talk about Oklahoma because everybody needs to know more about Oklahoma. Up in the Panhandle, that river that runs through Oklahoma City that they renamed the Oklahoma River? What was the name of that river before they officially renamed it the Oklahoma River for like 6 miles or whatever? What was the name of that river? It's one of the Canadian rivers. Now, is it the Canadian or is it the North Canadian? It's like Murray and North Murray, all right? Murray Hall, where my office is, it's not called South Murray, but it is along the south, right? But it's just Murray. So we have the Canadian River. People call it the South Canadian, but it's just the Canadian. Then we have the North Canadian. So which one is it? You have a 50-50 chance. The one that's the Oklahoma River. Okay? So you're going to learn something today, all right? The North Canadian River, right? Now the North, here's the real trivia. If you go to the Panhandle, anybody from the Panhandle? How many of you have ever been to the Panhandle? Ever? Okay? Just a few of you, it's geography majors, okay? The Oklahoma Panhandle is a little bit different. The folks out in the Panhandle, the old timers at least, they'll refer to everybody else in Oklahoma who doesn't have the blessing of living in the Panhandle. You know what they call us? They call us the downstaters, all right? So we're downstaters here in Stillwater. But the point of this is that the North Canadian River starts up in the Panhandle, all right? Or at least it comes through the Panhandle, and that's the main river, the main stream that flows through the Panhandle. But they don't call it the North Canadian up there. They call it Beaver Creek, sometimes the Beaver River, but it's the Panhandle. It doesn't have water all that much. So the Beaver Creek or the Beaver River in the Panhandle, and some parts of southern Cimarron County where they have the Rita Blanca grasslands. Really cool place if you've ever had a chance to go out to Cimarron County, the southern part of Cimarron County. I've been out there, and that's the only part of Oklahoma where I've ever seen golden eagles. All right, it's a fantastic place. Anyway, that's where we find some iridosols. See, I should work for the Oklahoma Tourism Bureau or something. All right, so but I shouldn't be put in charge of multimedia stuff because I'm pretty clumsy at that. So if we go back. All right, so soil orders. What we're talking about, iridosols. So we find the iridosols up here a little bit. That's the strip along the Beaver River, Beaver Creek. All right, next, entosols. And the way that you remember what entosols, the characteristics of entosols is that, remember the term recent, okay? Recent tosols. They are very, very young. So entosols are the youngest soils. They have, because they're young, they haven't had time to develop the organic and the mineral makeup of a soil. Soil scientists are concerned mostly, we talk about the different horizons, the A, the E, or excuse me, let's start up. The O, A, E, B, C, sometimes they say D, okay? It depends on who you're talking to. But those are the different soil horizons. Now, soil scientists are mostly concerned with what they call the solum, right? The solum, which is the O, A, E, and B. They're not really concerned so much with the C. Now, the solum, basically those horizons surrounding the topsoil, those are the critical layers, horizons of the soil for agriculture. And so those are the ones that they focus on. And intersols, to a soil scientist, may just not really be a soil. It's just kind of sediment or some kind of a deposit. Maybe it's an aeolian deposit, all right? But they're really not that crucial of a soil typically, because they're just deposited. Because they're simply deposited, they don't have any sort of, as you can see, any sort of development of layers, of horizons within their soil, or within the, whatever they want to call it. So it's deposited by fresh laying silt, either by air or by water. Sand dunes, great example. We have plenty of dunes in Oklahoma. When I used to live in Nebraska, and back in the early 90s, and in Nebraska they've got these what they call lurse deposits. And if you spell it, it's won't get this on camera. I don't know. All right, did I spell that? Is that right? You got it right? Okay. And you'll say it right. Good. So lurse, I've heard people say lus, which to me it looks like lus, and I've heard people say lurse. I guess it's a German word, but it's a deposit of very fine silt, and it has some really cool characteristics, and they are generally classified as intersols, but they get really, really thick. They develop very thick deposits in certain areas. Now, the most lurse deposits, it's assumed, were deposited by wind-borne, well, they're always deposited by wind, but their origins were in crushed outwash plains from glaciers, all right? So whenever glaciers are advancing and receding, they're depositing material, and glaciers crush everything, okay? They just crush anything in their way and grind it and just pulverize it. And that pulverized material is deposited as the glacier's melting back. As the glacier, anybody ever seen a glacier up close and personal? They're really, really cool. They're just gargantuan chunks of ice. They're all split, and it has rocks and dirt and stuff in it. But as the continental glaciers receded about 12,000, 15,000 years ago, as they were receding and melting away, a lot of that stuff was flowing out of the glacier. It dried eventually, and then got swept up in windstorms and sandstorms, and the patterns of prevailing winds and that sort of thing eventually deposited the stuff over time, long periods of time, depositing these wind-borne, silty stuff, very fine typically, into these deposits. And lurse deposits have a crystalline structure, sort of like, they tend to stack, okay? So this is one of the fascinating things. Has anybody ever seen lurse up close? I've seen a little bit out in the Panhandle, lurse deposits. I've got a few slides I should show you, but the thing about it is it takes a very, very steep, it'll even take a very vertical cut. So you can cut it into shapes. And in fact, in China, along what they used to call the Yellow River, up in northern China, people have carved houses out of the side of the slope. They basically carved caves into the slope, and they you can live in those for hundreds of years. So it's a deposit it's very easily formed and shaped, typically really well drained. But getting back to Nebraska, along the Platte Valley and the tributaries that go into the Platte Valley, there are lots and lots of loess deposits, and they've been eroded in just a typical little dendritic drainage pattern, and they've been incised very, very deeply. So just a small creek can have a cliff or a valley that's nearly vertical and can go down 75, 100 feet. And it's really pretty interesting. So you can actually ski on them in the wintertime when they get snow covered. All right, so loess deposits, depositional stuff, wind deposition. And we find entosols in desert regions, of course, where the wind is blowing sand and that sort of thing, other silts and stuff around. We also find them in around Black Mesa in Oklahoma. So anyway, don't worry about that. Another type of soil order is the gellisols, and this is a newer one, associated with permafrost. And so again, it's a pretty significant, amount of the Earth's surface. 9% of global land area is locked up in gellisols, which are essentially no good for agriculture, and barely useful for grazing livestock, because they're frozen most of the time, or they're always frozen in some cases. So they're associated with high latitude and high altitude environments. You might be able to find these in New Mexico, Colorado, as well as northern Canada and Alaska. We don't have them in Oklahoma. So I'm going to skip past this. You can catch it a little bit later. But just remember gellisols associated with permafrost, frozen ground. Histosols are another type that we don't have in Oklahoma. They don't make up a huge area of the Earth's surface. You do find them in Europe a lot, in northwest parts of continents, and areas that are wet and cool. England, Scotland, Ireland, you would find these. And basically they're associated with peat and boggy soils, areas that don't drain well. They tend to become very acidic. And that's where we harvest peat moss. And over time, those peat bogs, if they're covered up with sediment and placed under great pressure, geologic pressure and geologic time, then they can transform into a type of coal known as lignite. Sometimes they refer to it as brown coal. But it's actually used as a fuel in parts of the mountainous world, like Himalayas, and it used to be used as a fuel in England. So it's a soil associated with cool temperatures where the organic material doesn't break down much at all. The soil develops slowly, or the organic material builds up rather quickly, but there's not any real development of a mineral content there. So it's mostly the organic muck. And muck is a really good word for this. So swamps and bogs, for the most part, are what we're referring to. Not in Oklahoma. Inceptisols. Inceptisols. Think about that term. They are young soils. Their horizons, their definitions of, of layers are just beginning to emerge. So inceptisols are young and developing, and they don't have a whole lot of organic matter, and you'll just find it for the most part in the O horizon. There's not a lot of long-term weathering, so the components of the soil might be fairly large in size, not a lot of clay necessarily. But the minerals are, sort of in the process of breaking down. Generally, because these haven't been leached very much, because of the lack of churning of the organic material into the A horizon, generally they're not of great fertility. Okay, and we find these in some areas, find them in Oklahoma in the more sort of semi-arid parts of the state, in the western parts of the state, in the northwest Gypsum Hills area. So they may have been entosols that are beginning to develop. Inceptisols. Let's look at the map here and see where they are in the state. Inceptisols are those blue areas, and they're associated with the north sides. Again, here's, I guess, Black Mesa is considered inceptisols. These salt plains, and that sort of, this great salt plains right here. There's another really big salt plain right along the Cimarron River right there, around the North Canadian Beaver River. Cimarron's right here. But there are salt plains and playas. A playa is basically an area that experiences a lot of evaporation and leaves behind sedimentary salts. If you've ever traveled up in this part of the state, if you ever get a chance and you're up and you can stop and jump out of a river, take a taste of that river water. Okay, don't drink too much; you might get sick. But if you taste it, it's very, very briny, very salty. And in some of these areas where you get that river water spreading out over the land and evaporating, you get these developed playas or salt plains, as they call them in Oklahoma. Thomas Jefferson described one. I think it was along the Cimarron in Woods County around Freedom, right here. It's a really cool looking salt plain. Anyway, inceptisols. Now, the prize soil of all of the 12 for agriculture is typically the mollisol. Mollisols are wonderfully high fertility, high pH, generally high pH soils. So they're neutral to a slightly high pH, which is excellent for most crops. Usually referred to as a dark-colored soil. They develop in grassland, humid and semi-arid grassland environments. So tall grass prairies typically generated mollisols. Now, tall grass prairies are not found everywhere in the world. Mid-latitude tall grass prairies, at that. Mid-latitude tall grass prairies. Talk about that in a second. Where do you find them? Grasslands and mid-latitudes. There are just a few areas in the world where you find these. I just thought I'd ask you. Let's name 3. Number 1, mid-latitude grasslands. What do we call the region? The plains, Great Plains, yeah. Great Plains of North America, or in Canada they call them prairie forests. The Great Plains that run right up from basically West Texas all the way up into Alberta. Okay? Saskatchewan, Alberta, maybe certainly the Dakotas, Montana, everything east of the Rocky Mountains, all the way to, in terms of the prairies, we're talking about really all the way to the forests, okay? So grassland environments. What's another one? That's one of them. That should be the most familiar to you. Can you name two more areas of natural tall grass prairie land in the world? Okay, think of this. What are the areas of the world where they produce fantastic crops of wheat? The Tigris Euphrates? Not anymore. Maybe at one time. How about north of there in Russia? That's one of the three I was thinking about. The Russian steppe in Ukraine and southern Russia. You know, that's the area that Catherine the Great invited the Germans to come colonize. So they would grow wheat and they would produce food for Russia. And then later those Germans in Russia moved to the Great Plains and brought a type of wheat with them known as hard turkey red winter wheat, which is what we grow in Oklahoma. But they grew wheat in the Russian steppe, right, mid-latitude. And unlike the Great Plains, which is basically a north-south oriented region, right, on the map, this is the map, right? In the Russian steppe, it runs from Eastern Europe, right, all the way to about, halfway through Russia. And so it's a latitudinal region. It runs east-west. There's one other one I'm betting somebody can tell me about, and I'll give you a clue. This region is in a Spanish-speaking country. Region of mollisols, mid-latitude grasslands, fantastic small grain agriculture. These sound like quiz questions to me. Maybe test questions.
Argentina?
Yeah, so what's the region in Argentina, Alex? Ever heard of? Starts with a P. Sounds kind of like a brand of diapers.
Pampas.
Pampas, yeah, the Pampas. Pampas. You all were once in Pampas. Or maybe Huggies, I don't know. We always want Huggies for our kids. So the Pampa, or Pampas. That's a flat region surrounding Buenos Aires. And I should have said, not only do they speak Spanish, they speak a funny dialect of Spanish that nobody else in the world speaks anymore. Okay, Argentina. Vosotros. Anyway, the mollisols, they are characterized by what the soil scientists refer to as a molic epipedon. A molic epipedon. You're always needing a good molic epipedon. What's that mean? It means there's a dark, rich, thick, soft, highly organic surface layer. And it has a neutral to a high pH because of that grassland environment. Very dense vegetation developing, breaking down slowly, ever so slowly, and building up that organic layer. And grassland soils are better quality for agriculture than forest soils. Okay, even though some European, farmers used to think hardwood forests were the very best soil. Well, they're not as thick, not as high quality as the mollisols. But even those great mollisols, right, these fantastically thick mollisols, which are among the most productive soils on the planet and found in those humid, arid, transitional climates, even those fantastic mollisols can be lost in just a matter of weeks, months, years. And these are the types of soils that were plowed under in the high plains of the southern United States, southern plains of the United States during the 1920s and the 1930s. Okay? Plowed up, and when the droughts hit, when the drought hit in the late 1920s and lasted into the mid-1930s, this is what brought on the Dust Bowl. And the Dust Bowl then was a period, there's also, kind of a general, what we call sort of a vernacular region. There's no real definite idea of where the Dust Bowl was concentrated, but places like Texas County, Oklahoma, in the Panhandle, Cimarron County for sure, were in the heart of the Dust Bowl, that area that was plowed under for wheat production, and wound up blowing away in gargantuan dust storms. The dust storms of the Great Plains during the Dust Bowl laid waste to much of the better soils up there now. And you can still see the damage. Even though most of the cultivation has long gone, that's not irrigated. So dryland cultivation is pretty much gone in the Panhandle. Nobody in their right mind would try that. Almost all of the agriculture in the Panhandle, and Texas County in the center part of the Panhandle is the most agriculturally productive county in the state of Oklahoma now. It's all based on irrigation. And that irrigation water, as I maybe have mentioned before, all that irrigation water is coming right up out of the ground, out of the Ogallala Aquifer. Okay? So think about that. We've already laid waste to the mollisols, many of the mollisols, in an attempt to do dryland farming. Now we're producing a lot of agriculture with water in what some people refer to as a fossil watershed, something that was produced during glaciation. Now, I'm not against agriculture in any way, but it is actually being drawn down too far at times. But that's a different chapter, and we'll try to move on here. All right. So where are the mollisols? Mollisols are those dark green areas of the Panhandle and central Oklahoma. And this area right here, northeast Oklahoma, this was a humid tallgrass prairie back before extensive cultivation arrived, about the 1870s, 1880s. Before 1870, this area was largely a tallgrass prairie. And where there weren't tallgrass prairies, along the rivers, there were wonderfully huge cane brakes. Anybody ever seen giant cane? Arundinaria gigantea, great word. It's the big cane that you see on, beside the road sometimes around here. But these used to make up huge areas of the floodplains of these rivers like the Arkansas River, what's referred to as the Grand River, the Neosho River, which is all pretty much dammed into reservoirs now, like Grand Lake, and those. River that runs through here. So those are the Verdigris River. Those rivers had broad floodplains covered by lots of cane back in the old days. But they are also fantastically productive soils, and a lot of that's used for hay production today. Oxasols. Oxasols, they're associated with, as I've said before, the tropical areas of the world. We don't have any in Oklahoma. I've talked about them a little bit before. Because they are so heavily weathered, both chemically and physically weathered, they have very low CEC. And that's my phone going off to tell me it's time to stop. Anyway, these are the areas of, these are the soils in tropical forests, tropical rainforests, and tropical wet and dry areas where agriculture is pretty much not very productive. And I guess we can come back to spotosols next time, because I do want you to get out of here before the rush. And anyway, I'll put this online. It'll take a little bit, and you should be able to catch it. And you are here, and you don't really need to listen to it again, right? All right, be careful on the ice. There really is ice out there this time.